everyone, and thanks for having me. So today we'll be talking about the Internet of Things problem and methods for data flow control. This presentation is part of a paper that my supervisor and I worked in, and it will appear in the next month. So we will take a look at the basics of Internet of Things. What is the Internet of Things? Where is the Internet of Things and where it's being used? We will present some security needs in the Internet of Things. We will focus on data flow issues in the Internet of Things. We will propose our own solution using order theory, and we will finish by a conclusion. So, what is the Internet of Things? The Internet of Things is the connection of our everyday physical devices into the Internet. These things can provide us with information used to improve our lives, our businesses, or environment. Things in the IoT sense represent a wide variety of smart devices, such as sensors, workstations, and terminals. These smart devices collect and communicate data with each other. We call that machine to machine, or with us users through our IoT devices, such as mobile phones. The Internet of Things is used in a variety of businesses in all sectors. We will find it in transportations, in healthcare, in manufacturing, in energy, and in construction, and in all other sectors. A good example of the Internet of Things utilization will be the smart home. The smart home is a residence that has all its devices, such as lighting, air conditioning, and heating, connected to the Internet and communicating between each others. And it can be remotely controlled via time schedule, via mobile, or via Internet. A smart home can add convenience to our daily life. It is easy to use and can save us money and save the environment. In healthcare facilities, IoT may further advance healthcare with monitoring and automated administration of treatment. In factories, sensors on a production line can track heat, humidity, and vibration, and can provide us alert in advance, allowing a maintenance crew to schedule repairs. It can also track supplies and necessary component and provide alert when necessary component will arrive. It can also assure quality control and good quality manufacturing. To summarize the utilization of the Internet of Things, we have this figure that shows the interaction between the Internet of Things and several service sectors. It also shows all the devices that every service sector can use. So we will have, for example, public entities such as university. They can interact with various service sectors in time. So we can have interaction with building sectors, with network sectors, with transportation sectors. So it shows the interaction between the entities and the service sectors. Looking at the future of the IoT, statistics project a good growth through the years, and we can reach like 75 billion IoT connected devices by the year 2025. But with such big numbers comes big challenges, such as security ones. As we said before, as the number of a connected device increases, and their usage becomes an important part of our everyday life, security risk will arise, such as hacking, data leakage, and identity usurpations. To avoid that, traditional digital security trends must be re-examined, which are the device identity management or device authentication, protocols and network security, data security for privacy and integrity. So, what is the device entity management? In the Internet of Things, when things are plugged, they need to authenticate themselves prior to exchanging data. To do that, they have to be done automatically, because we don't have users sitting behind keyboards waiting to input information necessary to connect those things. So the AUT requires a strong device identity and chain of trust of each foundation. The second one is the protocol and network security. In the Internet of Things, the number of endpoints will overshadow all those in traditional IT projects. So with many endpoints, we'll generate many communication channels that has to be secured. In order to do that, we need optimal cryptography algorithm and key management systems, as well as security protocol to connect the devices into the Internet. Now looking to data security is the most sensitive subject in the IT protections. We have two aspects of data security. First of all, the data access control, which control data transfer between only two things. And we have the data flow control that control all the possible things where the data of certain other things can flow through a sequence of access. We will focus on the data flow control. As we know, the IoT is a highly distributed and highly dynamic environment where data can flow through objects in complex data configurations and in complex data interferences. So, for example, we have various data from different users. We will have various data for different services. For data security, it is important that only certain data flows be allowed. So in all cases, data should not flow to unauthorized parties. If not the case, sensitive data may be stolen, altered, or even held for ransom. For example, in a healthcare system, we have two different sensors, a heart rate sensor and a motion sensor. They may be separate things, monitoring for different people. So we don't need to have interference between those data. So data must only be accessible by the treating staff for each person and isolated from other things or other people's data. This raises a lot of questions. How can we set up data communication channels between things so data originating from one thing can or cannot reach other things? Given certain data flow originating from an entity, who are other entities that can access this data? And which are the most and the least secret entities on an Internet of Things system? To respond to these questions, we have to go back to the literature. In the literature, there are only few results in data flow access. All other works on IoT are for other are for other issues, such as attacks, intrusion detections, and the existing ones only refer to the lattice model of Denning by proposing applications, variant, or improvement of it. We propose our own model that is based on order theory and not on the lattice model of Denning. So in our model, each entity will be labeled with an attribute, which is a allowed content that can hold. A channel is placed between by calculating the inclusion between those labels. So if we have two entities, A and B, and each one has their own label, if the label of E is included in the label of B, so there will be a communication channel between A and B. The resulting data flow graph needs to be simplified. The simplification of this data graph will result in a partial order of component. And this can be dynamically done every time a new entity enters the network. So for more explication, we have the following example. Let's say we have the following data flow graph. We see that the data flow graph is impractical because it has too many channels that has to be removed. To do that, first of all we will search all the connected components and regroup them into single entities. And after that, we have to eliminate all the transitive channels. We do that using a transitive reduction algorithm. This results, for example, we have the entities B, C, and D who are interconnected between them, so they can know basically the same thing. So we regroup them in a single entity. The result of this simplification will be a partial order of component. A partial order of component is a multi-level system. As we know, the multi-level system meets the requirement of secrecy and privacy because data can go only in one direction, from the least secret level to the top secret level. So we have if we assign security level to this partial order of component, A will be the least level secret, and the most secret entities will be E and F. Now from this partial order of component, we can construct an equivalent data flow graph that have the minimal channel possible. So it will be minimal transitive. We have an example in the IoT utilizations. Let's say we have healthcare facilities that has 3 patients. Each patient have sensors monitoring their heart pulse and blood pressure. And the two patients will be treated by staff different from the third patients. So we need to define a communication channels that construct a data flow graph that meet privacy and security requirement, which are data generated from sensors can flow only to the treating staff. Data generated from the sensors cannot flow to other patients. And all the data must end in the chief of medicine's devices. Now by applying our method, we have the following results. The top results is the data flow graph with all the entities of the system. We have H and E and G that represent the sensors for the 3 patients. And every entity has the label. For example, the pressure detector of SAM has a label, SAM press. We call the label of this data will be SAM press. This there is a channel between H and A because the label of H, Sampres, is included in the label of the nurse, of his treating nurse. So it will be a channel between H and A, and so on for all the other entities. So the simplification of this data flow graph shows that we have the first treating staff, the nurses and the doctors, form an equivalent entity, which is normal since they all know the same thing, the same data. And we have a second equivalent entity, which is the second treating staff. So they are regrouped in the ACE and the BFD entities in the partial graph, in the partial order component graph. So, and by removing the transitive channels, we will get the partial order of components. This partial order of components allow us to answer all the questions that we asked before. We have all the data generated from the sensors flowing only to the treating staff. For example, the H flows only to the ACE and don't flow to the other treating staff, the BFD. And we have the G sensors that flow only to the BFD treating staff. It cannot flow to the ACE. And we can have all the entities that the data generated from H flow to. They are G, ACE, L, and K. This can be called the area of the H, the data generated from H, and we can conclude that the top secret entities are the one of LLK, corresponding to the chief of medicine, because no data can flow from there. Now, as a conclusion, we saw that the IoT is the new technological revolutions. One of the biggest impediments of businesses implementing IoT is security. Data flow control is critical in the IoT security. We proposed our method to achieve that using the partial order theory. And this method can be implemented by incorporating it into the best known routing protocol for IoT. But at this moment, this needs further research. These are the references used for these presentations. And thank you for your attention.